Welcome back to this third in a series of 8 videos on Introduction to Spreadsheets. In this third video, it's going to be very short. We're just going to show you how to apply what you learned in Screencast 2 about relative cell references to making some columns of data for formulas, mathematical formulas, like you might see in a pre-calculus class, or anytime you want to understand how formulas work, or you just want to convert a formula from a symbolic format to a numerical format. So we're going to start here with a blank spreadsheet, and I'm just going to create a column. One I'm just going to label as X, and the other one I'm just going to label as X squared. Now this isn't going to compute anything, this is just a label. I'm going to highlight, center, bold, and underline so it looks like a heading for a table. A lot of times we are given formulas to work with in mathematics and mathematical applications that are given as formulas as symbolic format, but it's helpful and often enlightening to change that to a table of data so we can really see what the formula does. And we're going to use Excel to do that. So I'm going to make a table of data for the formula y equals x squared here. Over here in column A, I'm just going to enter in several values of x, starting from -5 and going all the way to +5 in steps of 1. Okay? Just 5, not 56. And over here, I want to calculate the square of whatever is over here. I want to calculate whatever x happens to be, I want to calculate its square. Now, this is a perfect example of where a cell reference is going to be useful for us. So I'm going to enter in equals, because we always do that when we're having Excel calculate something. And I want to take the thing that is over here, the x, I'm just going to click on it and raise it to the second power. So I'm going to hit enter, and I get 25, of course. And now, because I entered in not just -5, but I entered in a cell reference, if I drag this formula down, it's going to create an entire column of data where it calculates the value automatically. As you can see, because I had a relative cell reference, it changed from A2 to A3. It just means not literally A2, but whatever happens to be to the left of the cell that I'm putting the formula into. So down here, for example, we see it's A7. So I'm going to create another column of data over here. So I'm just going to wipe all this out here by having it clear the contents. And I'm going to create an exponential function now, 2 to the x. So I'm going to have equals, and this time I'm going to type 2 to the whatever this is, power. There it is. And I can drag that formula all the way down and instantly get 10 more calculations of 2 to the x without having to type in anything else. I can also calculate something different, like, for example, e to the x. Now, e to the x is a little bit different in calculus. This is a very important function, of course. There is no number e here in Excel, so we want to show you a bit of notational trickery here. Instead of raising e to a power, the command to do e to the x is exp of x. This is a fairly common notation for e to the x in computer programs, so it's probably a good idea to see it now. So exp of a2 is going to raise e to the a2 power. exp, of course, stands for exponential function. So there's e to the -0.5, and when I drag this down, we're going to see all the values of e to the x. And of course, there is the number e itself, e to the 1. I can even go back and change this one more time to something, say a base that's less than 1. This time I really do need to change this back to 0.8 to the x, to the not the x power, but the a2 power. And as I drag this formula down, there are the values. And one of the benefits of doing tables of data this way is that I can go back and change the base, drag the formula down, and very quickly get a sense of how these different exponential functions behave. For example, when I had 2 to the x or e to the x, I saw that was an increasing function, and here I see that it is a decreasing function. We can also do things a little bit more practically. Let's suppose I want to create a table of data that converts Fahrenheit to Celsius temperatures. Let's go over here to column D, and I'll put in degrees Fahrenheit and degrees Celsius. And let's put in some degrees Fahrenheit, say -10, 0, 10, 20, and so on up through maybe 80 degrees. And over here, I'm going to use a formula to convert the temperature. This is a pretty readily accessible formula here. Here I've got it from Google. If I want to change Fahrenheit to Celsius, there's my formula I need. So I need to take whatever's in the F column and subtract 32 from it, and then multiply by 5 over 9, and I'll give you my Celsius. I'll scoot that off to the side again. I'm going to enter in equals again because I want Excel to calculate something, and I'm going to take the Fahrenheit temperature minus 32 times 5 divided by 9. And then this will convert to Celsius, and now to get the other temperatures, I just got to drag the formula down. You see there's our Fahrenheit to Celsius conversion factor. So using relative cell references is very useful in a number of mathematical senses too. Anytime you want to convert a function from a symbolic format, say a formula, to a numerical format or a table of data, we can do that very easily and with a lot of control using spreadsheets. In the next screencast, we're going to see about a different kind of cell reference called an absolute cell reference that will allow us to do all kinds of very interesting and complicated things and make nice formulas that do all sorts of things for us. So I will see you there.